So what is a complex engineering problem? We're going to dive into that today, and let me tell you, it is so much more than just, building a bridge or writing some code. We're about to see that the real cutting edge of engineering is all about tackling messy, unpredictable, and really, really human challenges.
To get a feel for what a complex problem really looks like, let's just jump right into a real-world situation. That number on your screen, that's not just a statistic. It represents a huge public health crisis happening in Bangladesh, and it's having this profound, devastating impact on families and whole communities. Which, of course, brings up a really important question. And here it is. Could tech actually help us spot this early? We all know that getting an early warning can make a massive difference with this disease. And this is exactly where a group of engineering students saw a chance to do something meaningful. They asked themselves, could we build something? Could we use our skills to see the signs before it's too late?
And that idea, well, that leads us straight to our first case study. They had this really ambitious goal to use artificial intelligence to try and predict depression, not in some sterile lab, but out in the real world where people are actually living their lives. So, what was the game plan? Well, the core idea was to build a machine learning model, one that could predict depression by looking at a person's social media activity, specifically Facebook, since that's what almost everyone uses in Bangladesh. Then, the final piece of the puzzle was to wrap it all up in a simple, easy-to-use app. Sounds simple enough, right? Huh. Not so fast. And almost immediately, they smacked right into a huge wall. For the AI to have any chance of being accurate, it needed a ton of personal data. But to get that data, you have to convince real people to share incredibly private stuff from their social media. And right there, you see this classic conflict. The technical need for data is fighting directly with the human need for privacy. So this is what gets us to the heart of our explainer today. What is it about a project like this that makes it complex? Because it's obviously not just about the technical skill or the lines of code. It's about trying to find your way through this maze of interconnected challenges.
All right, so let's break it down. What actually makes a problem complex? There's a pretty common framework in engineering that points to a few key traits. We're going to walk through 5 of the big ones, and you'll see every single one of them showed up in this depression detection project.
First up, you just can't solve these things with one skill set. It's impossible. I mean, think about what this team had to do. They had to be academic researchers, digging through all the existing studies. They had to be data scientists, figuring out how to collect and clean up information. They had to be machine learning experts and web developers. It's like they had to wear a dozen different hats from the very first day. In this one, this perfectly shows the kind of tightrope walk these engineers were on. On one hand, they wanted a super accurate AI model, but on the other, they were stuck with a limited set of data from just one platform, Facebook. So every single decision became a trade-off, this constant balancing act between what's technically perfect and what's actually possible. Here's another thing. With complex problems, there's no instruction manual. You can't just Google the answer. There was no existing formula for how to build a depression detector from social media. The team had to dig in, analyze a whole bunch of different algorithms, weigh the pros and cons of each, and pretty much invent their own solution through trial and error. Oh, and this is a huge one. These were computer science students, right? Suddenly, they had to become students of psychology and mental health. To build something that was actually responsible and helpful, they couldn't just stay in their comfort zone of code. They had to really understand the human side, the nuances of depression, ethics, patient privacy, stuff that's way outside their normal classes. And finally, these problems are always a system of systems. It's not one big task, it's a whole chain of connected pieces that all depend on each other. The data collection has to feed the training module, which has to power the detection algorithm, which has to work flawlessly with the front-end app. If any single link in that chain breaks, the whole thing can just fall apart. Okay, so that's a deep dive into a software problem. But does this framework hold up when we're talking about, physical hardware? Let's switch gears completely and look at a challenge that was sparked by a really terrifying real-life event. This is a direct quote from the source material, and it is just chilling to read. A horrible, real-world accident where a safety system completely failed and a child got trapped. This wasn't some theoretical problem. This was a life-or-death emergency that absolutely demanded a better solution. So in response, a different team of students set a new goal: create an external anti-snap door system. And I want you to notice how they approached this. It didn't start with gears and circuits. It started with people, understanding how and why someone might get trapped. Then they moved on to the hardware, the physical device to force the doors open. And all of that was supported by software to monitor the whole system in real time. So you can probably guess where this is going. Was this elevator project also a complex engineering problem? Let's run it through our 5-point checklist and see what we find. And would you look at that? The exact same pattern pops right up. Once again, it took a whole range of skills, hardware, software, mechanical engineering. There were conflicting goals, like making the sensor react instantly without triggering false alarms. Just like before, there was no instruction manual. They had to invent a new system from scratch. And yep, it forced students way out of their comfort zone, this time into the world of mechanics and electronics. It's the same DNA, just in a completely different project. So what's the big takeaway here, looking at these two totally different projects? Well, it's about something much bigger than just getting a good grade. It's really about a whole new way of teaching people how to solve problems. Because when students get their hands dirty with projects like these, they're learning something so much more important than just how to code or build a circuit. They're learning how to become genuine problem solvers. This kind of experience is literally the training ground for the innovators who are going to go on to tackle the world's biggest, toughest challenges. And this right here is why it all matters. At the end of the day, complex engineering isn't really about the tech. It's about people. It's about designing things with empathy, forcing you to think about the real-world consequences of your work and demanding that you work with people from totally different fields. It's what drives the kind of innovation that doesn't just make a cool new gadget, but that can quite literally save someone's life. So, there you have it. From predicting mental health to preventing elevator accidents, the anatomy of a truly complex problem is surprisingly consistent. And it kind of leaves us with one last big thought. Climate change, food security, access to clean water, they're all complex engineering problems. So the real question for all of us is, which one should we solve next? Thanks for tuning in.